10 for your response too.
The question says, determine the change in temperature of the solution that results from the dissolution of urea. And this question is worth 1 point. And when you look at the graph, you see that the initial temperature is 25 degrees Celsius and the final temperature is 21.8 degrees Celsius. So to find the total change in temperature, you do the final temperature minus the initial temperature, which is 21.8 minus 25.0, and that equals negative 3.2 degrees Celsius. Question 3 says, according to the data, is the dissolution of urea in water an endothermic process or an exothermic process? And this question is worth 1 point. And when you look at the graph, you see that the temperature is decreasing throughout the time, which means that the process for the dissolution of urea in water requires energy, and therefore it has to be endothermic. The fourth question asks, assume that the specific heat capacity of the calorimeter is negligible, and that the specific heat capacity of the solution of urea in water is 4.2 joules per gram Celsius throughout the experiment. And it says, calculate the heat of dissolution of the urea in joules. And this question is worth 2 points. So it asks you to assume that no heat energy is lost because it says the heat capacity is negligible, and therefore you set up the equation Q plus MC delta T equals 0, and then Q has to equal negative MC delta T when you just move it over to the other side. And then you have to find M, which you can figure out by using the grams of urea that were given, which is 5.13, and add it to the grams of water that were given, which is 91.95. So the total mass is 97.08 grams. And then you use this value and substitute in for the equation. So you do Q equals negative 97.08 grams times the 4.2 joules per gram degrees Celsius and multiplied by negative 3.2 degrees Celsius, which was given to you from the last question. And that ends up being 1.3 times 10 to the third joules as the heat of dissolution. The next question asks to calculate the molar enthalpy of the solution of urea in kilojoules per mole, and it's worth 2 points. And you use the equation delta H equals Q over mole solute, and you have to find the molar mass of urea, which is 60 grams per mole, and then you do stoic to find the moles urea, and you know that they gave you 5.13 grams, so you divide that by the molar mass to get the number of moles, which is 0.0855 moles, and then you plug that in for the moles of solute, and you had the value of Q from the last problem, so delta H is 1.3 times 10 to the third joules over 0.0855 moles, which equals 1.5 times 10 to the fourth joules per mole, but the question is asking to find the enthalpy in kilojoules per mole, so you convert it and it becomes 15 kilojoules per mole. The next question asks to use the information in the table and to calculate the values of the molar entropy of the urea at 298 degrees Kelvin. And they gave you a table with the accepted values of delta H and delta G of urea, and you just use the equation go home to supper and plug in the values. So delta G was negative 6.9 kilojoules per mole, and you set that equal to delta H, which is 14 kilojoules per mole, minus T delta S, and the temperature was 298 Kelvin, and then you just solve for delta S and you get 0.070 kilojoules per mole, and which converts to 70.1 joules per mole Kelvin. The next question says, the student repeats the experiment and this time obtains a result for delta H of urea that is 11% below the accepted value. Calculate the value of delta H that the student obtained in the second trial, and this question is worth 1 point. So you want to find the delta H that is 11% less than the accepted value, so you take 0.11, which is 11%, and multiply it by the accepted value, which is 14, and that gives you the value of the error, which is 1.54 kilojoules per mole. And then to find the value of delta H in the second trial, you do the accepted value minus the error, which is 14.0 minus 1.54, which gives you 12.5 kilojoules per mole. And then the last question says, the student performs a third trial of the experiment, but this time adds urea that has been taken directly from a refrigerator at 5 degrees Celsius. What effect, if any, would using the cold urea instead of the urea at 25 degrees Celsius have on the experimentally obtained value of delta H? And so this question is more of a thinking question. So you know that there'd be an increase in the obtained value for delta H because the colder urea would have caused a larger change in temperature, because when you heat something when it's cold, it'll change farther more than something that's already hot, then you heat it. So if you think of it like that, if you have something colder, then you heat it up, there'll be a greater change in temperature and therefore a greater change in delta H.